As explained in one of my previous videos, bilinear interpolation requires specifying values at locations which form enclosing rectangles. In effect, this means there are some restrictions on where you can perform velocity analysis and mute definition. The SUBINBIGCSV program knows these restrictions and will only pass traces at locations useful for VLANs or mutants. This video contains details about SUBINBIGCSV setups. This video also shows how to use the traces from SUBINBIGCSV to perform interactive velocity analysis and interactive mute definition. Multiple Seismic Unix programs for 3D use bilinear interpolation. And bilinear interpolation requires specifying functions at locations which form enclosing rectangles. See my video on bilinear interpolation for details. One way to get enclosing rectangles is to specify inline and crossline indexes. The intersection of those indexes form enclosing rectangles. The SUBINBIGCSV program allows you to specify inline and crossline indexes. Their intersections are a set of CDP numbers which form enclosing rectangles. But more than that, SUBINBIGCSV also allows you to increase the size of the CDPs at the intersections. Only traces that are within these larger CDPs are passed to output. This is the size of a normal CDP. This is the size of a CDP which has been extended by one cell in the inline direction and two cells in the crossline direction. An important point here is that, by default, all traces within this larger CDP are renumbered to the central CDP number. At this point, we are finished discussing what the SUBINBIGCSV program itself does. Next, we are going to create all traces of a fake 3D survey, then use SUBINBIGCSV to pass only traces at locations where we are going to perform interactive velocity analysis and interactive mute definition. These are traces after the Create 3D script. These are the only traces passed by our setup of SUBINBIGCSV. We now have only 6 CDP numbers, but each of these CDPs contains traces from the larger size that we defined. The reject 544 script deliberately deletes all traces of CDP 544 in order to show you the effect of missing CDPs during interactive picking. Now run the velocities script. The script presents some information about how to use it and also some advice. You can pause this video to read it, but we are going to see it in action anyway. You need to click the mouse in the contour plot. Then move the mouse and type the letter S to pick. You will not see a reaction to typing the letter S. Move the mouse and type S until you have all the picks you want. Then type the letter Q to proceed. Note that you can alter the colors and other factors in the script. After picking, an NMO-corrected trace plot is displayed, and also a graph of your velocity picks. Remember that we deliberately removed all traces of CDP 544. This is the result. The script actually recognizes that there are no traces at this location and uses one null trace instead. This gives the plots you see. Just make one pick and proceed. The reason to do this is that we need CDPs to form enclosing rectangles. We cannot just leave out a CDP location. After that, there are 4 more CDPs within this dataset to pick. This is the file created by the script. The CDP with no traces only has one pick. Its values should be replaced with good values from nearby locations or some general area values. A setup of SUBINBIGCSV to apply the velocities. Make sure to put the 3D grid into the parameters, otherwise the velocities will be linearly interpolated rather than bilinearly interpolated. It is a good idea to apply these velocities to the trace file that was used to do the picking. This gives an overview of the velocity correction across the survey. This is a file produced by the SUBINBIG script. You may find it useful. This is how the interactive velocity script knew that CDP 544 was missing. I bring this to your attention because SUBINBIGCSV will produce a similar file from the stackvel velocity file, except that it will also contain interpolated velocities at specific times. And that file containing interpolated velocities can be input into spreadsheets or plot programs. Onward to interactive mute definition. The script presents some information about how to use it and also some advice. You can pause this video to read it, but we are going to see it in action anyway. Click the mouse in this plot. Move the mouse and type the letter S to pick. You will not see a reaction to typing the letter S. Move the mouse and type S until you have all the picks you want. Then type the letter Q to proceed. You must pick in increasing offset order. Note that you can alter the maximum offset and other factors in the script. You can also alter how the mute itself is applied. For instance, you can alter the amount of taper that is used. Next, there is a plot of the applied mute. If you see this plot, it means no traces exist in the input CDP. Just make at least one pick anyway. Or you can decide to make more picks. In either case, the effect will be shown here. Continue picking until there are no more CDPs. The output file. As with the velocity file, you are advised to apply the mute to the traces that you used for interactive mute definition. After deleting the first line, you can also input this file into the SUBINBIGCSV program and output a CSV file containing mute times at specific offset distances and read it into spreadsheets or plot programs. Documentation of SUBINBIGCSV, just so you can read it here. And finally, a few concluding remarks and points.